In this example, we are going to use L'Hopital's rule to take a limit. All right, so we have the limit as x goes to 2 of x squared plus x minus 6 over x squared minus 7x plus 10. So this is a rational function, right, because it is the the division of two polynomials, x squared plus x minus 6 and x squared minus 7x plus 10. All right, so first thing that we're going to do is plug in the 2 and see what we get. When we plug in the 2, right on top we'll get 6 minus 6. On the bottom we get 14 minus 14, so we wind up with 0 over 0. So this is indeed a L'Hopital's rule problem, and you always need to double check that you are in that situation, 0 over 0 or infinity over infinity. All right, so L'Hopital's rule says take a look at the limit of the derivative of the top over the derivative of the bottom, right? So the derivative of x squared plus x minus 6 is 2x plus 1. The derivative of x squared minus 7x plus 10 is 2x minus 7. So we're going to take a look at this limit. When we take this limit, so this is the limit as x goes to 2, and we plug in the 2. On top, we get 2 times 2 plus 1, which is 5. On the bottom, we get 2 times 2 minus 7, which comes out to be a negative 3. So we get negative 5/3 as the limit. So L'Hopital's rule says that the limit of the original function also has to be negative 5/3. So notice that this is one of the same types of problems that we did in Unit 1 on limits. In that unit, what we did was when we got a 0 over 0 for a rational function, we factored the top and factored the bottom and then canceled out the common factor in there. So L'Hopital's rule allows us to do those types of problems without having to factor, but at that point in Unit 1, we didn't know how to take derivatives. So now we can use L'Hopital's rule on these problems.